Stan Gibilisco here, proprietor and operator of amateur radio station W1, GV, Whiskey 1, Good Vibrations. When you put up an antenna, it's always a certain height above the ground, and that height affects the angle at which the maximum radiation will occur relative to the surface of the Earth. In general, the higher you put the antenna, the lower the angle of radiation will be. If the ground were a perfect conductor, right at the surface, like a copper plate, and your antenna were 1/4 of a wavelength above ground and horizontally polarized, that is, a dipole, for example, 1/4 wavelength above the ground, then the maximum radiation from that antenna would be straight up. Sometimes such an angle is desirable, for example, on 160 meters or 80 meters, when you desire a short communications range by means of the ionosphere. The ground wave from a horizontally polarized antenna only goes a few kilometers out from the antenna before ground losses cause it to fade away, and the real ground does have losses. The losses in the real ground, compared to a perfect conducting ground, also produce an effect, I'm not sure what it's called, but the effective RF ground plane lies a few feet or a few meters below the surface of the ground, which you observe when you look at the Earth, at the ground. When you mow your yard, for example, you're mowing the surface of the ground physically, but the radio frequency surface lies several feet or meters beneath you. The better your ground actually conducts, the closer that surface is to the real surface. But you never know exactly how far that is. If you want to work DX with an antenna, there are generally two options. You can use a vertically polarized ground plane antenna with radials with the feed point at least 1/4 of a wavelength above the surface of the Earth. That's one way you can do it and guarantee low angle radiation into the sky. Another way that you can do it with a horizontally polarized antenna is simply to get that thing up as high as you possibly can. A half a wavelength is a good choice generally if your antenna, if you could measure the distance of that antenna from the effective ground plane which lies underneath the surface of the Earth. But you can't really know exactly what that is. So my advice, if you say want to work DX with a tri-bander, a Yagi designed for 20, 15, and 10 meters, or now I suppose they have a 5-band beam somewhere with traps for 20, 17, 15, 12, and 10 meters. Or maybe it's just a random wire, horizontally polarized, up in the air, with the intent of working DX. If that's what you want, to work DX with a horizontal wire, in general, the best thing I can tell you to do is get that antenna up as high as you possibly can. In general, the higher up you put your antenna, if it's horizontally polarized, the better it will work for DX. At high frequencies, of course, at very high and ultra high frequencies, the ground plays a minor role, if any role at all, in the propagation of the signals. I'm talking about high frequencies, meaning 30 megahertz and below. Stangibelisco signing off, saying 73 and so long, which, regardless of polarization, regardless of effective ground versus surface of the earth ground, regardless of all other factors that have ever existed in the human species. So long, da-da-da-da-da-da.